Hello everybody. Thanks for coming here for today's Friday talk. Today we have Laia Ribas to explain a very special topic. We will see what she has organized for us. Laia presented the PhD in 2000 at the Autonomous University. Then she did a postdoc in the Imperial College in England, and in 2009 is here. Her specialty is to work on the fish immune system and reproduction of fishes, with the topic is to increase aquaculture processes. And as I said today, she's going to talk about an expedition that they have organized to go to Mars. So I think we are very curious to know what she will tell us.
Okay, can you hear me? Yes? Okay, so first of all, thanks a lot for being here. Also, Ramon, for giving me the chance giving me the opportunity of explaining this project. Its name is Ipatias, and it's a multidisciplinary, intergenerational female Catalan crew travels to Mars. So I wanted to begin with this talk with some historical images playing this movie.
Command override off. Engine arm off. 113 is in.
6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
And we're getting a picture on the TV. Hopefully no trouble to walk around. Really is. Go ahead, Mr. President. This is Houston out.
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call ever made from the White House.
Roger. Looks like Neil is coming in by there. 11. Do we copy? And, okay, it's in
45 years ago, almost to the minute, Jack became one of the last Americans to land on the moon. Today we pledge that he will not be the last, and I suspect we'll be finding other places to land in addition to the moon. What do you think, Jack? Where's Jack? What do you think, Jack?
Okay, so I'm sure that you all know these images and you've seen them before. So yes, since 60 years, when the human made a step on the moon, we were imagining and we were desiring go to another place. And this place, since it's Mars. And why Mars? This is just the magazine that I booked in my village, in the library, just to show the importance of Mars. And because why Mars? So in our solar system, there are 8 planets. These 4, they are young and they are made by gas, and they are not habitable. Then we have these 4 here, closer to the sun, which we have Earth, and these are terrestrials. They are made by rocks, so we can step on in these planets. The problem is that Mercury and Venus are closer to the sun, and then they are not habitable, are not in what it says in English, the Goldilocks line. So we have to just look at Mars for the next planet that we have to explore and we want to step on. So during these 60 years, it has been 24 different satellites exploring Mars and 6 rovers going and driving along this planet, giving us a lot of information, a lot of evidence that we can step on, and giving us information of this planet. For example, we can compare our planet Earth, Earth versus Mars, and we have some similarities, also some differences. For example, the day. Can you hear me well? Because yeah? Or maybe it's, no? Here better? Is better here? Okay. So Okay, so we have 24 hours a day, while Mars has 24.6, so very similar, although we might have some difference in the circadian cycle. Then the year is much longer, it's double on Mars. The gravity, this is an important factor that we have to take care of when we will travel or live on Mars. The temperature, the mean temperature is super, super cold. The temperature, it ranges between minus 140 degrees and 20 as the maximum, depending on the season, because there are also seasons as here. The oxygen is also a problem because it's a very low amount of oxygen on Mars. So the sunlight is less because it's farther from the sun, and the radiation is between 40 and 50 times more than what we have on Earth. So definitely we have to plan very well how we are going to live and how we are going to settle down a Martian settlement there. So these 60 years of research has been, we have been performing very great, no? It has been a very important research. But the question here arises, who are behind these scientists? Who are these scientists? And if we go to the statistics in Europe, the answer is that most of the scientists are men. So are men in the STEM career. STEM goes for science, technology, engineering, and math. Most of them, 60%, 70% mostly, are men. And if you look at the scientists that belongs to aerospace-related science, this is even more. It's 80% of men when compared to the women that are studying for being an astronaut or for being space-related science. And if you look for astronauts or those women that have been done a work, space work, so going outside the universe, with, for example, in the International Space Station, only 7 of them are women. Not even in science, but also in our society. When we think about some social referent, we think about men, no? Men as a scientist, men as an astronaut. Even when we are going to see a movie, the actors are men who represent the astronaut. So we somehow we have to change this, and this is how Ipatia was born. Ipatia is a project that wants to inspire women in STEM careers. It's a project that is multidisciplinary because we are 9 women with different disciplines in the side of STEM careers. Intergenerational because there are different ages, and also I would say intersectoral. Intersectoral because we work in the public but also in the private sector. You can, we have a website. You can also have a look at our website. We are also very active in the social networks, in Instagram and Twitter. We also create this logo by Anna. Anna is a crew member. She is an artist. She's an engineer, but also she's an artist, and she has more than 30,000 followers in Instagram. She draws comics. And why we gave this name, no? Ipatia of Alexandria is considered the first woman to be a scientist. She was astrophysics, she was a philosopher, she was a mathematician, and we gave our project to this name as honor her. A similar way that also Alejandra Menava also directed a movie that is named as Agora. If you haven't seen it, I think it's a very good movie, so I really recommend you. So Ipatia has 3 main aims. The first aim is to perform high-quality space-related research. The second is conduct outreach and science communication activities. And the third, and very importantly, is to inspire and promote women in STEM role careers. So what we are going to do? So this project, we are going to travel next April in Utah, in the desert of Utah, that there is this Mars Desert Research Station, the MDRS. This is a station that studies how, what we have to do, the research that is related on Mars, what we have to do when we get a Martian settlement on Mars, no? And since then, there has been 23 years, because it started, this facility started 23 years ago. Every 15 days, there are different crew that are going there. And it took us 2 years almost to get permission to go in there. So you have to write a project, Each of us, a member of the crew, have to write a project for the research that you want to do, and then it's like a project application. You can be approved or not. And our case was approved, and we are going to travel in April. And then these facilities, what it has, basically it has the minimum to survive. It has this hub that is 8 meters, a cylinder of 8 meters, which has the kitchen. It has a lounge, it has 1 bathroom and 6 bedrooms. Then we have the greenhouse. This is where the biological agriculture experiments are taking place. This is only the fresh food that we will have available. Then this is the scientific dome. It's like our lab that you can perform biological and geological studies there. Then there is this RAM, that this is repair and maintenance models, mostly for engineers, people who are going there. And then we have these nice 2 telescopes, the MASS telescope and the robotic observatory, one for studying the sky during the night, and also for studying the sun, the movement of the sun. And then we have these rovers for going around the desert, because it's super big, the desert, and I had to take the driving license for rover, so I hope I will be able to drive one of those. So these are some images from the last crew that Mariona went there. You can see that why this Mars Desert Research Station, what it has, this desert, what it can give us, this station, why it's so important. So it's located there because of the geology of the desert. It reminds us this red planet, the Mars planet is named as also red planet because of the iron, the high content iron it has. And it's no green, no vegetables, only rocks, only red and brown for many, many extensive areas. Then we have a research place for develop our research. Different kind of research related to space can be developed there. Strategies would be, for example, those challenges when we are going on Mars, or the problems that we might have. For example, we cannot go outside without a spacesuit. We have to travel. We have to walk outside with a spacesuit. We cannot walk outside anytime we want. We have to ask permission to Earth that we want to go outside, so we are not allowed to go outside these facilities. Also, for example, the limitation of the communication is also an issue. We had to buy a very powerful radios, especially when we are going outside with this expedition with our rovers. We also have to get these big radios because we always have to get contact. We cannot, never, we cannot stop to be in contact with all of the crew members. And the daily life. The daily life is also a challenge because, for example, we only will have water to survive these 15 days. We are already aware that we won't be able to shower every day. So I will have to take some different ways to get myself clean. So the limitation of food, the food will be astronaut-like food. So everything will be dry. And the only nice or fresh vegetable we will have, we will get it from our vegetable garden. As I told you, these facilities are connected with this corridor that you can see here now in this video. And yes, our daily life would be like being confined, as we were with the pandemics, being confined there, living together, the 7 members that we've never met before, by the way, all of us together, but this is going to be a challenge. So I'm very happy to present you the Ipatias crew. So I present you Mariona. Mariona, she is the IP, she's the principal investigator. She had the idea of having this project. She's doing a PhD. She's an astrophysics, and she's doing a PhD in MIT in US. And Carla Conejo, she's a biologist. She's specialized in outreach in science. She has been working in La Pedrera for many years. And I think that one or the nicer thing of this project is that it's led by 2 younger women, no? The PIs are younger than most of the rest of the crew. So I think this is super nice and different also in somehow. Then we have Ariana Farres. She is a doctor in math. and she's worked in the NASA. In NASA, she's now living in US for many years. Then this is myself, that you know me already. We have Núria Hack. She's a journalist. She's a freelance, but now she works in Catalunya Radio. She's specialized in outreach communication of science. Then we have Neus Sabater. She's a doctor in physics. She is a ICREA. She's a researcher at ICREA, but she won the Professor Csic in the last oppositions. And she also has a company, a private company, thanks to a 2-year grant that she got. Then we have Cesca. Cesca, she's an engineer. She works in France in the Airbus company, a company that they are designing rockets. And then we have Anna and Elena. They are the 2 backups of our crew, because if some of us cannot go, so she has to know everything, all our projects, because they have to be able to travel in case that one of the 7 that we are going to US are not able to travel. And Anna, she's an engineer, and she's an artist of our crew. And Elena, she's the youngest. She is studying 2 careers. She's doing physics and also mechanicals and electric engineering. And because it seems that she has, I don't know, because she has also works in Synchrotron here in Cerdanyola, and also she is an elite athlete. She's performing Olympic shooting, and she's going to Olympics in the next Olympic Games. So it seems that she has a lot of time, or at least the hours are more extensive than us. Okay, so this is an overview of how we are going to distribute in the MDRS. Mostly I will be in the greenhouse, because I'm the Green Hub officer. I'm the responsible of taking care of this greenhouse. It means that I have to take care of the plant. I have to take the right amount of water. I have to also harvest, so I can collect some vegetables that other crew have done. I have to create my own harvest, but also I have to plan, if possible, for the future crew. So this is my main project, but also because I have another project that I will explain you here, I also will be in the scientific doom part of the MDRS. And also, we have 4 more women, because we realized, as being this an outreach project, that we needed some kind of support of disseminating the research that we are performing. And this is why we consider that it was a good idea to have 2 teachers, Marina Domènech and Mireia Cunmasdival. She are a teacher of secondary and primary school. We have also a lawyer, Cristina Lázaro. She is taking care of all the paperwork, because now Ipatia is become an association. And also Celia Ventura y Gavarro. She is also an artist, and she's a writer, and she paints very well, and she's helping us to make all of this outreach work. Another nice thing that we had in this project is that, because we need this spacesuit, we contact with Sabrina Thompson. She's working in the NASA. She's a rocket scientist and atmospheric physicist. And she created a spin-off of this company named Girl and a Space Club, because she is designing a spacesuit only for women, adapt to our body, not for the man body, but for the woman body. So she's now creating our spacesuit with our logo. So we are very happy. We still don't have them. And also we have created some merchandising objects, like this jumper that I'm wearing today, some t-shirts for using them in the MDRS, some flags, and some stickers. Okay, so which are the MDRS projects of Ipatia? So Ipatia is mainly organized with 4 blocks, or 4 topics. We have the block of astronomy, engineering, space biology, and outreach and communication. So I'm mostly in these 2, the space biology and outreach communication. And for those who know me, you might think, why Laia is doing a space biology? How come it happens? She's been working with more than 20 years with aquaculture, so that's very weird. And the reason I wanted to explain today is this. This project, it's another project, it's a NUA project. I was invited to design a city for 1 million people on Mars during pandemics, in the middle of pandemics. And this city, it was for a contest in the Mars Society. And maybe some of you remember this because it was quite mediatic because we were not finalists, but we were in the top 10 finalists. And it was the APIs and most of the research team were Catalan, so it has some kind of an impact media here in Catalonia and also abroad. But here, working in this project, I realized the importance of being multidisciplinary in terms of space related. So not only the astronauts are the ones who will arrive beyond Earth, but also we need other disciplines, very important disciplines. We need architectures, we need psychologists, we need biologists, we need artists, we need everyone in our society that needs to take a part of this journey to go to another planet, to go to Mars, no? And this is how I start to study this, because I remember once Ramon asked me to give a talk about this project, and at the end, just time flies. I had not a chance, so I just wanted to give you some bit of explain you a little bit this project. So this project, when we designed this city for 1 million people on Mars, so it has 3 principles. First, it has to be self-sustainable to growth. It has to be resilient because Mars environment is very hostile, so it's very hard, it's very tough to live there. And it has to be an exciting place to live because of that, because it's not an easy place to live, because it has a lot of challenges. So with these 3 principles, we built this city. The first challenge was, okay, so because we have all of these environmental problems, how we are going to build our city? So if we build the city outside, we have natural light, which is very important, but then we have problems when we have an impact of the meteorite, the radiation is very bad. If we go inside, and we put a hole inside and we make our buildings, everything will be fine, but then we will die because we don't have natural light and we don't want this as human. So the solution was, let's do these buildings inside the cliffs. Mars has the largest cliffs in the whole solar system, are super long, I think it's 10 times than Colorado. So we take advantage of these cliffs and we build all these models on the wall. So this is an image of the city. So this was, the architecture team was super great. We made a very good job. And also, we designed these mirrors. These mirrors attract the sunlight, because you have to think that we are farther, Mars is farther than Earth, so we need to attract the light as much as possible. So we designed this mirror system to attract this light, make them different because they have different shape based on the model that you were living. And this is also important, no? This green, because remember this desert in Utah that reminds us Mars? No green. So this was important part of having some green in our cities for going camping or walking around. And during this project, I was involved in two groups. So one was the social service. So I was working in thinking and, okay, if you had the chance of starting from the beginning, how you would like to have a society, which are the values, the way that the education. So I had to do this social service infrastructure. For example, I had to count how many hospitals we might need for 1 million people, the universities require, the nursery, etc., and also how many gardens that we might have. For example, here I say you can have some fish in these lakes that we might have in our gardens. And then I was in this team. This was the most important team I worked with. And this is the life support system. Life support system is defined as what an astronaut needs to survive beyond Earth, to survive in the universe, to survive on the planet, to survive in the International Space Station. So we had to think about how we can provide food for 1 million people on Mars. And we had to thought about this sustainability, to recycle, all the energy has to be recycled, and which were the vegetables and which were the food that we want. So at the end, we ended up with this graph. So our diet would be mostly based on vegetables, 50% of crops, and the other one coming from microalgae, which are very easy to produce. Also some bacteria to close the cycle. And then here it was my job. I say, I want to bring fish on Mars, and they say, okay, so let's bring them, and also we can bring some poultry. But these are going to be just for special days. 4% of our diet will be based on big animals, which are here as small. So that was a good thing, because when we had this contest, we said in our city, Nua, you would be able to eat sushi from a restaurant, because we thought about having fish there. So I had to plan how many tanks we needed, how many water, how many, talking a lot with engineering, with architecture, designing all of this. And I'm sorry, because 10% of the food would be based on insects. So I think this is not only for Mars, it will happen soon on Earth and Mars, and also there are many countries that are also based on insect food. Cellular meat that are being developed in US. There are a couple companies that are creating hamburgers based on meat, culture meat, and other kind of living organisms. So yes, this is just an overview of how this Nua city would be. These are the cliffs with all the modules that would go for to build the city. These are all the panels, solar panels, where all the agriculture, all the crops would be taken place. Yes, and I just wanted to show you a video that it's this video we did for this context, and it's just a summary of what we have done so far. Yeah.
Hi, I do architecture and urban planning.
I do conveying.
I do future scenarios.
I do architecture and graphic design.
Life support systems.
Chemical engineering.
Space psychology.
I do architecture.
Mining and rock mechanics.
Fashion and art.
I'm an astrophysicist.
Architecture.
Astrodynamics.
In-situ resource utilization and manufacture.
Architecture.
Brain-computer interfaces.
Space engineering. Architecture.
Planetary geology and geochemistry.
I do economics with fish.
I do planets.
I do rocket science, and we are Sonnet.
Okay, so this is the city, how we designed the city, or how we imagined the city of Nua. So this was my way that I started working with space-related science. And then I was so fascinated, and I realized that definitely biologists are also important for designing a city and for being on Mars. So between all of these, among all of these environmental factors, which some of you that you know, I'm interested in understanding how the environmental factors and challenges affect fish development, in particular fish immune system and reproduction. So one I've never worked with was gravity. So I thought that would be a good way to start, because gravity is an issue. So what happened on Mars is that the gravity is lower, it's 30%. So if we walk or jump a little bit like this gift, you might think that our way to walk on Mars is going to be like this. No? And if we weigh 100 kilos here, on Mars we will be slimmer, we will weigh less. So it's good if you want to go for a diet, you go there, and that you don't have to eat just vegetables. You can eat ice creams. So yes, but if you look at the literature, there is this nice review from 2021 that explain the different data that we have so far in humans, mostly by astronauts, but also from human cell cultures. And here on Earth, we are studying a lot of hypergravity. because it's very difficult to generate microgravity. So on Mars, there is microgravity when compared to Earth. But it's very difficult to study microgravity here. Therefore, most of the studies that are here on Mars are performing hypergravity. So there are many research also going on. So as you can see, we have problems with the nervous system, vestibular system, immune system, musculoskeletal system. This is more famous and maybe might ring a bell because most of astronauts have problems with their bones when they are outside, no? on the planet, outside in the universe. So yes, so definitely we have problems. Our body is not shaped for living beyond Earth. So this is a problem. We have to understand what's happening with these alive organisms when we are subjecting them in a non-Earth conditions. So we have to study, and we need to do it fast. So inspiring this NUVA, no? This was very inspiring project for me. Together with Guillem Anglada, he is the PI of the NUVA city, we decided to start working on this factor. So he as a physicist and me as a biologist. So we start working in zebrafish. The zebrafish is a great model, is a great animal model, not only for aquaculture related research, but also for medical research. It's used around the world. So all the results that we might find could be for both sides, for research based on non-aquaculture, but also in aquaculture, which I'm interested in. So here in the Institute of Marine Science, we have the fish facilities downstairs. So we breed a couple. This is what we normally do. Every week we do this, basically. We have male, female. We breed the animals, and then we have the eggs. And then with Guillem, we designed this device to generate hypergravity. This device that is based on a centrifuge, and it has two arms with the gondolas, and then we had to calculate precisely the angle that these gondolas perform depending on the speed to identify the gravity that we were creating. And here there are these 96 wells plates that we put one of the fish individually, and we can study and we can observe. And this is our model. So here, this is the centrifuge. I'll show you a video. Oops. Yes. So we leave the animals here for 5 days. They are fine. Not all of them, but they are fine. So we leave them for 5 days. Why 5 days? Because ethically, you can skip the ethical permissions, but it's always good to have permissions, so we have permissions. But this zebrafish is why it's so popular, because you can work with this fish during these 5 days, and you can skip the ethical permissions. So these animals, we stop every day for 5 minutes, maximum 5 minutes, and then we analyze the survival, the hatching, the physiology and the behavior of these animals. And then, very interesting, we start looking at the molecular changes. And we made a study of gene expression, studying the epigenetic related genes, some of them, and studying epigenetics by a global DNA kit. This work is basically done by Marcela. She did a master together also with Guillem, and she got a grant for it. And then she's working now in the lab in the institute, and she's taking care of these experiments. So the survival of these experiments, we found differences after 2 days of this hypergravity effect. There was a difference, these animals died more, a little bit more, but at the end, those that survived, they survived fine. The hatching, at the beginning we had some clues or some evidence that the hatching was not performing great, but then we found out that it was because of the plate we were using. So when we changed the plate for a flat plate, we didn't find any difference for the hatching rate. So those animals that hatch, they hatch well. So the animals that they die here, they hatch and they die. That is the conclusion, because of the stress of the experiment. Then we have some teratology, those that die. For example, they have problems with the skeleton. We have here also the tail that is curved, some body that has not a very good shape. I'll show you some images. This is the control larvae, which is living happily. And the one here on the bottom has some difficulty of swimming. No? So we also are spending many hours looking at all of these videos. And we could make some plots, and we've seen so far differences, very significant difference between the positions of these larvae inside these wells. Yes. So when we look at some just three gene expression related to epigenetics, those that are not, do you know what you don't know what our epigenetics are? Is basically marks in the DNA, the changes in the function of the gene. So you can explain changes in the function of the gene, but they are not alter the nucleotides of the DNA. And these marks, these epigenetic marks, are heritable from one cell to the other one, and they also from one generation to the other one if this cell memory is hard enough. So in the way of studying this DNA methylation pattern, by doing a simple analysis, well, a kit, that you cannot, you see only global methylation patterns, we saw that there was an hypermethylation of those animals that were treated during 5 days under gravity conditions. So far here, it's very significant. It's not a big change, but it's very significant. And the idea is to continue studying these changes in more deep detail. So going back to Ipatia, the MDRS projects, when I had to write the report of my application, I had to write one project, but because I'm super excited and I'm super happy with this Ipatia, so now I'm already working with 4 projects, one related more to space biology and 2 related in the outreach and communication. So let's start from the space one. Yes, when I wrote the project, I thought about this NUA city and how we have to recycle everything. So I thought, okay, I will bring my fish, I will feed them with some microalgae, and because of that, and then I will do some challenge, environmental challenge, if I can, with gravity. And then I also contact with Francesc Godia he is the principal researcher of Melissa project from the European Space Agency. This is a huge project. It's a very relevant project that is going on for 20 years. And this is a kind of building a sustainable way to have this circle of auto-sustainable. So I contact with him, so we were happy. But then, before going on holidays on August, the MDRS told me, you cannot bring animals because we are not allowed to have animals due to ethical reasons. And then I thought, okay, so I have to change completely my subject and my project. But that was not a problem because I think it was even better because I had to inspire again. And this is the project one. It's named as Aquaculture on Mars. It's mostly support for the Institute of Marine Science, this institute, also with a company working on the Universidad Pompeu Fabra. So I thought, okay, what do you want to do? What do you want to disseminate? Which are the topics that you want to explain to the society? No? I made this kind of exercise. And I said, okay, I guess I want to do 4, I want to explain 4 subjects. So first, aquaculture, because I'm working in aquaculture, so I want to show the importance of aquaculture. The second, the zebrafish as an animal model, because I've been working with animal models for many years, and I think it's a great model, and it can be rich with other, with many research topics. Epigenetics, because we've been working, and it's a very part of our research team, and DNA sequence as a tool to get all this information, all the DNA information that we are looking at, and to show how we can now get all of this due to the high technology that we have now. This DNA sequence is very important for us. And then I thought, oh, okay, so how I'm going to explain all of this? And then I was inspired and I thought about this, of course, with this with the project that we are running in the lab. And with this device, Nanopore, which name is, Nanopore is a company with a Minion. Minion is a sequencer. It's a device, very small device, like a USB, that you can put it in the pocket. And when I checked on the website, it was funny because I had on the website this picture that is from the space, no? And you can see the Earth, and it says, our goal is to enable the analysis of anything by anyone, anywhere. And I thought, wow, this is for me. I'm going to the desert, and there is nothing, I'm alone, and it's anywhere, no? So let's go. So the idea is to have samples that we run here in the Institute and analyze them, because this is very expensive. So I had a minimum of 3 samples to make it sufficient statistically power, because and the idea is to sequence by this methodology. But the first issue is that although I've been working with genomics for many years, because this is a brand and this is new, I didn't know, and I still not very know how to use. Then I found this solution, Roger Anglada from the UPF. So Nuria also, together with Sylvia, you know, we went to UPF with Roger, who is sit there. And I know him for a long time ago, and he's also very active in disseminating the science. And together with Ipatias, they also know him. So we contact him and explain him our project, and the UPF was very collaborative. So the idea is that we, together with Sylvia, are going to the UPF, learning this methodology. And it's good that Sylvia is also coming, because now we have this technique here in our institute to be available, no? And we are learning. So basically, because this technique works different from what we have, we can sequence directly the DNA. You don't have to treat the DNA. You don't have to cut the DNA. So you can work with longer reads and direct the DNA. So you can see the epigenetic marks directly there, or SNPs, or whatever you want to study. So we are working on that. Okay, so then I'll go for my second project. My second project is the Martian Bottle, is the title. And this is together with Elena. Elena is the youngest member of the crew. She and her colleague had designed this bottle cap. It's a bottle cap that is fantastic. And they got awards. They got international and national awards for designing this bottle cap. This bottle cap has this solar panel on the top, getting the water, getting the sun. And then it has 2 different bulbs, one from light, sunlight light, and also for the UV light. So the idea is that with those that are not potable water, you can, with the solar, with the sun, you can have energy to make this water drinkable. And with the energy of the sun, you can have light. So this is very important, for example, for remote places, and also for people places that they don't have water or they don't have light. So only with this bottle cap, they have light and they have water. So this is why they got this award. And so the idea with Elena is now we are working on how is the best place, because this is super new. So we are now working on designing an experiment to treat the water from the greenhouse, and then we will analyze the water with this kit. This is a commercial kit that it can detect fungus and bacteria. So the idea would be how good is this filter, or how good is this bottle cap in order to get this potable water. Yes, so now I'm moving to the 2 projects. My third project, it's titled Ipatias Cars. Ipatias Cars, I'm working together with Ruben. Ruben is a colleague of mine, and he created Lastuf, a company that they have cars for playing and are football and basket cars. And he has been so popular that he's now selling these cars on Amazon. And this Christmas, he was the top 3 most seller cars. And so that was super good, no, for them as a company. So we had the idea of creating cars only for our mission, for Ipatias. And we are now working with this together with Anna, our artist, that she is designing these cars, and together with Ruben, we are doing these play cars that I hope that you might like to play. So we are working on that. And then my fourth project is under construction, and because I wanted to involve directly a school, and why not to involve my kids' school. It's a public school in El Masnou, and yes, the idea would be, I'm still working on that, but the idea would be to make them actors for being on Mars and trying to connect, send them videos as much as possible, and to do some analysis, maybe with their garden and my greenhouse. So I'm still working on that. I might explain you when I'm later or when I'm arriving back. Okay, so yes, so just I will finish the end of this talk with the impact media that Ipatias has had so far. With these 2 years, because we started 2 years ago, we had 45 media communications and 23 different conferences, and we already have some plan for this next future. So we've been very active, particularly getting fundings, because there is no, this is an outreach and this is a project without funds, so we had to fundraising some money. But one thing that I'm happy and we are happy with is that this astronaut course. This astronaut course, we worked together with Abacus. The Abacus, this Christmas, not the previous Christmas, we had this in the magazine of the Abacus. Those that goes to Abacus, maybe you heard. So we prepare a course based on these 4 topics, biology, astronomy, communication, and engineering, and was very welcome. And we had more than 300 kids that wanted to go. These courses were granted. And I'm happy, very happy to tell you that since 1 week, all of this material that we had to prepare for some months, now it's released and it's available for all the schools in our country, together with Generalitat of Catalunya. So all the schools have available all of this work that we have done. So basically, this course was designed because of the kids could do some exercise, some experiments at home. So there has to be nothing related, so not sophisticated thing, no, but just materials from home. And we had to create some sheets with exercise and questions. So, and some videos. We also had to do some videos because this course was online. And then, well, it was a fantastic experience. The kids love it, I think, and they sent us amazing images. This course also, apart from these videos and these activities sheet, they had also tales that were written by our writer, Celia. And also we wanted to, for each module, we also gave or explained the life or the research of one of the women that we decided to explain and to get as a reference. And we made one communication with online with all of these kids. And last September, we went to the CCCB in Barcelona, and it was super nice. We gathered all in the big hall there. There were also families coming from Valencia just to join us to this activity. And yeah, it was very nice because all the kids bring some posters, because one of the activities was to create a scientific poster, and they had explaining, and they make a fantastic job. So for example, in my case, in the biology, I was leading this module. Together with Seska, we created this biology module. So the experiment that we thought of was extracting DNA from a banana. And then we could explain the importance of DNA, why is DNA, what does it mean, what we can do if we, for example, I also explained the transgenics, no? Why transgenics, why we need transgenics. And also another activity was to design or to make a draw of a banana tree, a kind of a garden on Mars. So they had these nice models or just fantastic drawings. And just this because me here presenting the impact media that I've had so far, like in 2 magazines. We've been invited in radios, in several radios, also in Teratology with Lydia Heredia, we went there. And also in the Woman Days, no, in the Science Woman, the 4th of February, and the 10th of February this year, we also had Ipatias was there also showing, explaining the project. Okay, so just to finish, the actions that we will do during this mission, we have 3 main actions. So before we leave, the 12th of April, we will have a news conference that is organized by Núria Har, our journalist. She has invited different Catalan media, so I hope that it will have impact media, our project. Then in the middle of the mission, we also have booked the Observatory Fabra, which Elena, all the 2 backups, the Elena and Anna, will go there to this emblematic observatory, observatory, and we will contact from Utah, and we will have real-time communication. And then when we will come back, we have already booked a talk and a presentation in La Fundació La Pedrera, the 16th of June. So this is our actions that are now planned. And just, this is a website, our website. And something very important that I didn't mention, but I don't know if you realize that Ipatias, this project has this number 1. And this is on purpose, because we really want to have many Ipatias. We want to have many Ipatias following us. And we are working hard to get funds to have this possible, no? To have more Ipatias and to get more women involved in and promote women involved in the STEM careers. Okay, so thank you very much for your attention.
For this very, very interesting talk. I think we have time for questions. I start with one question. In the Nuba city that you have been designed, what the water? You didn't talk about the water.
The water, yes.
That's an issue? Or?
Well, it's an issue, but on Mars, the water that is now available is on the polars, on the 2 polars that are frozen. So the idea is to get the water from there. And also it's believed that under the water, under the soil, there is also water. So that's the thing. But it's limited, as here also, it's limited. There is a storm with a lot of sandstorms. It's also a problem that I haven't mentioned, but you can have 1-2 months a sandstorm that can cover the whole planet with 100 kilometers of sun. And the water is taken from these polars, and then you have to recycle the water. So this is why it's important. And this new city was a very good exercise to realize that I knew that we were doing very badly here in Earth, but I was amazed of how bad we are working here because we are just storing too many resources, natural resources, like too much. Yeah.
Maybe you can tell us about the budget of the whole project and where do you get the funds from, and just to get an idea how, if someone wants to repeat something like that, what's the problems with that? And so.
Yes. Well, actually, when the costs, because one thing I didn't mention, for going to the MDRS, one of the crew members had to already been there previously. So Mariona, the principal investigator of this project, she was there in 2019, and now the budget for being there, it's triple, so it was like too much. So all the money that we thought we had for future missions, we don't have now anymore. So just to have an idea, for example, for being there 15 days, I think it cost 3,000 per person to stay there only for 15 days. So where we are getting the money from? Well, we are still fighting or try to get the money because it's not easy. But we have this Abacus collaboration. We have Generalitat de Catalunya, Fundació Catalana Pedrera, and yes, also the Institute, and yes, different public and also, for example, collaborations like giving us some kits or some material, this kind of collaborations. But so far, now we don't have money for having another Ipatia. So we only have to pay the Ipatia one.
Laia, thanks very much for your overwhelming talk and for giving voice to women in a way, and to girls. Right? I have one question. If the problem in Mars is microgravity, why are you studying hypergravity? I know it's very difficult to go for microgravity, but what sort of results are you getting from that can be extrapolated to a problem that in a way is microgravity?
Yeah, that's the thing. Basically, because it's a problem that we cannot get microgravity here on Earth, except if there are some instruments, some devices that are called clinostat, that they are going around, they would like to create a vector zero. And our idea was, okay, we designed this experiment, doing as much as we can do, is do hypergravity. We prove and we show that things are happening, because you have to think that there are not a lot of studies related to fish. There are some, but not too many, and not in molecular studies, there are not too many. And then the idea would be, okay, we go to the European Space Agency, and they have this instrument there, the clinostat, and then if you still like, or they still like the proposal, the best scenario for us would be to send the samples to the fish to the station, to the space station, International Space Station, because there are how do you say these convocatorias? Calls, yes, sorry, calls that you can apply these calls for sending things, and then the astronauts, when they are going to the International Space Station, they bring your sample, they make you experiments. So the idea of doing this, also establishing protocols to work with this. So this is basically, because if I had this clinostat, or I had this possibility, I would do. Just a way to start with also, I guess.
Thank you, Laia. Congratulations, because I think it's a super cool project, and I'm fascinated. Can you tell us more about in Utah? You said that you're gonna eat vegetables grown by yourself there, but you're gonna eat just that, or you have a backup plan if they don't grow or something? Or
the backup plan is open a soup and then put it in with the.
Okay, so you're gonna take more things with you just in case, no?
No, it's not allowed. So the MDRS is providing us the food. So this is a challenge because I'm a little bit terrified with this part. So my responsibility as a Green Hub officer is that I have to take care of the green garden there. So the idea is I can eat what the other crew have harvested, have done, no? Have planned. I can do my own, so I can only, with 15 days, you cannot do too many things. So at home, I've been doing some trials with lens and germinats. Well, they work quite well, so in 4 days, I think that we will be able to eat some fresh vegetables from this. And then my idea would be to also get something for the future crews. But I think that because they close at the end of spring, maybe we don't have to, we are not obliged, because they close, and I think that every year they are like, during summer they stop, and then they clean and they make a maintenance, and I think the garden start again, so we are not obliged to do it.
Okay.
This was the answer of your question? Or
Yeah. I was curious to know more about how do you feed there and everything. Also, you said about the recycle, that you will recycle things. Can you tell us more about that?
Yeah. Well, the recycle is that we are isolated, so we don't have nothing apart from what we have. So the last meeting we had in Ipatias, they told us, make sure that you have everything you need. Like if you need, I don't know, a needle for your experiments, you have to bring it because there is no needle there. So there are some, because I have a list of things that have this lab, but there are not too many. So I will have to bring everything. I will have to bring gloves, I will have to bring tubes. So in terms of recycle, for example, the bathroom, all of this, then it has to, in a big tank, and then it's kept. The water is just a small tank of water that we have to calculate the liters, so these are the engineering part. And yes, this is basically what we have to do. We cannot throw away the things, no? We will have to take care of everything.
Okay, thanks.
Well, the thing is that, so when 2 years ago, when we accepted this mission, they say, okay, but you have to think that we will only have some communication, internet communication, and this is reserved, or this is kept for the journalists of your crew, because first we have to report every day to Earth. So this is how we said we are on Mars, and this is like a linguistic way, no, to communicate on Earth. Every day we have to say we are okay, we've been doing this, tomorrow we are going to do that, and this is only, like, this communication only is for this. If there are less internet communication available, then we can call and to do things with our families and friends. The thing is that it seems that now that we have this masked satellite that is going around, that was in Catalan, I think, last week. So this satellite, Elon Musk, is also going to this part of the desert. So now it seems that the communication is much stronger. And it's, now we have communication the whole day, it seems. But our Mariona and Carla, they already said us that we are not allowed to communicate. So we won't be able to use the mobile or anything except some days or some hours during the day. Because the idea is that you have to do a simulation of what is going to happen on Mars. And on Mars, you probably won't have this communication. So the idea is to simulate as much as possible. And this is the way that we will work on. So we won't have internet or communication. And if something happened, for example, an emergency happened, and this is why we also had to buy these radios, because I guess that if these Elon satellites there, I would be able to call, no? But we also had to buy very powerful radios, because when we are with our rovers, we have to call, and we have to call because we separate, we always have to have communication. We have these radios. Because when Mariona was there in 2019, they had problem with one of the crew. They got lost and they lost the communication. And then you have to communicate to Earth and say, look, I have this problem. And then they break, the mission is broken. And then it's like, okay, it's failed. Because this mission, it has to last 15 days, and then it's like failing. The simulation has failed. So you don't want this to happen as much as possible, of course, if there is an urgency. But we don't have the last village and the petrol station is 2 hours driving, so we are there isolated completely. And one of us Ariana was taking care of these medical first aids. So she had to do a course. I hope won't happen anything.
Thank you, it was very interesting. My memory is now not very good, but I remember in very early in 19, so at the end of 80s, there was a project that had similar to that, of course with less technology, because it was 30 years ago, but at the end it didn't work. And did you hear about that and take into account the problems they have to with the technology we have now, solve it.
But which project? Sorry, I didn't understand. They go to the
Remember,
MDRS?
but was isolated. It's like this. Was
But they
isolated.
are, every 15 days they change the crew. So this kind of.
It was in United States in a desert
Yes.
place, and they isolated. It was it was not. There was not this network. There was just
okay.
a sphere. I don't remember the name. There was for years working on that, and then was something that was wrong. But maybe, and it was something about the carbon cycle that was not working out.
I don't know about this.
I have to look at it. But I thought that maybe, taking into account the difficulties they have at that time can help now.
Well, no, actually, all the problems and all our daily life, we have to do a report. And this report, it goes as a science report that goes to the Mars Society, because all of the information, analysis, our daily life that we will have during these 15 days are reported, and this is for creating this Martian settlement on Mars. So this is not just because of fun. This is based because the purpose is scientists to make a Martian settlement. So all of the crew that go there are scientists, most of them, but there are other disciplines. But at the end is to have many information, to have a simulation of what is going, how it looks like living on Mars during 15 days with this limitation of well-being. But yeah, I mean, I don't know this, because this station was created in 2000, but I'm sure there are many examples like this one.
So humanity is going to live in Mars in the future? That's 100% sure? I mean, you seem to be so convinced.
I think so, yes. Yes, we will arrive for sure. It's estimated in 2000, the most optimistic would be 2040. When we create NUA, we set 2050. So this city was designed for lasting 50 days, so 50 days in 3 different phases to expand and to create 1 million people. So it's not that 1 million people is going to go there. So first phase was 1,000 people, then it was 10,000, and then so on. Sorry, but the worst for the limitation is the rocket. So we don't have a powerful rocket to arrive on Mars, because also you have to think that when they launched this in 2020, they launched these 3, the rover from US, the China, the satellite, and United Emirates, Arabs. They also sent a satellite. So they did it at the same time, the summer 2020, because every 2 years, the Mars and Earth are closer. Otherwise, because of the movement, they are getting apart. So this travel has to be every 2 years. And even this, there is a distance that is estimated about 9 months. So first challenge is being inside a rocket, a spacecraft for 9 months, then arrive there and do the settlement, the Martian settlement there. But the rocket is still not designed. But Elon Musk has a lot of interest, and he's spending a lot of money on that. But I think that yes, one day we will arrive for sure, sooner or later. So we have to be prepared.
So I think if there are no...
Sally wants to ask.
We are sure that we can find these materials there, or we will change some other...
You mean the natural resources?
Well,
Mars?
yeah, while you were in Mars,
yeah, well,
you need to think that...
Yeah. Well, we know a lot about natural resources on Mars, because there has been a lot of explorations there, and it's the
minerals and...
Yeah, there are many studies. There is a lot of studies on there. So there are different proportions. For example, oxygen, carbon, iron, the different proportions, but they are very similar from the ones here found on Earth. Actually, in this in NOAA report, we have a table, if you are interested in, with the different composition of how much we have on Earth, how much we have available on Mars, and the comparison. And for example, well, you said something that maybe I can also give you a little bit of answer of you, because one of the challenges also is going back, no? And also 9 months, and the weight is also a challenge, no? A weight of this battery or this energy for having this landing this craft, no? And for example, Neus, the researcher, the project that she will bring is based on batteries that are made by paper. And she's designing and works with a paper battery because they don't weigh. So the energy that she will use will come from the urine. So going back to the recycle that Christina asked me, one thing that we will recycle will be our urine, because she will use it as energy as a battery. So the many things to study.
So I think we can leave it here. Many thanks for your talk, Laia.
Thank you.
And thank you to all.
Thank you. Sí, sex appeal. Ay, no sé cómo es.